POC question. We have been given these two statements about regular languages and we need to identify which of these statements is or are correct. The first one is saying that every infinite regular language contains an undecidable language as its subset. For this, it would be better if we take some counterexample and try to prove it. Let us say L is some regular language given by A star, or you can say sigma star, can also take A plus B closure, anything. We are just concerned with taking some regular language and then we'll try to prove if it is possible to find out any undecidable language as its subset. So we may come up with some language in which, let us say, this is the language we are considering, and L1 is another language consisting of strings such as a raised to n, where this n cannot be generated using any algorithm. N is not any prime number. It is simply a number which cannot be generated by any algorithm. So we can say that there would be some sequence of numbers, let us say 4, after that 69, then 123, something like that. A sequence of numbers which cannot be generated using any existing algorithms. We can say it is randomly chosen or something like that, in such a way that it's not really possible to actually come up with an exact algorithm to represent this language. So this L1 will then become an undecidable language, and it is definitely a subset of this language L, which was regular. In the same way, we can also come up with some other languages, and even if it is not possible for us to actually come up with a language there, but we can say one thing for sure, that if L is a language with a regular expression as A star, then it has any number of A's including 0. So out of that, we can definitely come up with some language which would not be possible for us to express mathematically. Or if we consider this one, then it would be possible for us to come up with such a sequence of A's and B's which cannot be easily generated using any existing algorithm. And in such cases, those languages become undecidable. So it's definitely possible to have a regular language which would have undecidable language as its subset. So this becomes true. Now coming to the next one, every finite language is regular. Now this one is easier to prove. Let us say M is some language consisting of a finite set of strings W1, W2 and W3. So is it possible for us to come up with a regular expression for this? We can simply say that the regular expression for M would be W1 plus W2 plus W3. We can select any one of them. This is the regular expression itself for the language M, and it can definitely be represented by a finite automata if we have been able to come up with a regular expression for it. Hence, every finite language is also regular. We can definitely draw an automata for that. Maybe it will require infinite number of states or a large number of states, but it would definitely be possible to come up with it. So every finite language is definitely regular, and hence both of these statements are true. The correct option would be C.